I need to find out the voltages V1 and V2 here, and also power dissipated by the resistance 3 kilo ohms and 20 kilo ohms, and also power supplied by the current source. So what I will first do, I will try to find this current. Let's call it I1. So we have three parallel branches, 3 kilo ohms, 5 kilo ohms, 20 kilo ohms. First let's find the parallel equivalent of 5 and 20. So I will redraw the circuit. It will be like this now. So parallel of 5 and 20 will be like this, 5 times 20 over 5 plus 20, which is 4 kilo ohms. And here we have 3 kilo ohms. Sorry, there was a 1 as well. I missed that 1 kilo ohms, so that's also there. So here is 30 milliamps, the current source. So now we can find the current I1 just by using current divider rule. I1 will be, the total current is 30, the two parallel paths are, here is 3 and 1, which is in series, these two, so that will be 4, and here is also 4. So basically 4 plus 4 times 4, since they are same resistance, it will be just half. So the current I1 will be 15 milliamps. That's the current I1. V1 will be I1 R1, whatever the R is here, 3 kilo ohms, so times 3, so that will be 15 times 3, which is milliamps here, and kilo ohms there. So when multiplied it becomes volt, 45 volts. Milliamps, 15 milliamps and 3 kilo ohms, so multiplied gets volt. So that's there. And then power will be VI, so V times I. V is 45 and I is 15, and the unit will be milliwatt here. So that's 675 milliwatt, because it's 45 volts times 15 milliamps. So that's done there. Now I need to find the current through this one, because this voltage we need to find out. So we know that the current that goes in this direction is 15 milliamps, the remaining current, and these 15 milliamps will be divided between the 5 kilo ohms and the 20 kilo ohms. So let's do this. 15 is going that way, 15 milliamps, and we have 5 and we have 20 and 5. So we apply current divider rule again, and it becomes now 15 over 20 plus 5 times the other one, because we are interested in this current, so that will be 5 here. So 15 over 25 times 5, so that is 3 milliamps. That's the current. That's the current I2, the current through 20 kilo ohms resistance. So voltage V2 will be 20 times I2, so 20 times 3, which is 60, 20 kilo ohms times 3 milliamps, so that will be 60 volts. And P2 will be V times I, so V is 60 there and I is 3, so that will be 180 milliwatt again. Now we need to find the current supplied by the resistance, by the current source, which is here, this one, 30 milliamps. So all we need to know the voltage across this one. So the current power supplied by this one, the current source will be current VI. So voltage is, we already have seen, the voltage is basically the voltage drop here, which is 60 volt, because that's there. This voltage is 60 volts, V2. So V2 is the voltage across the current source. So 60 volts there, and times the current is 30. So that will be that much milliwatt, which will be 1800 milliwatt, and which is 1.8 watt. So that is the power supplied by the current source.